Hello everyone. In this video, I'm going to talk about Gensim, which is nothing but generate similar. So we will understand the importance of Gensim in this video. Gensim. So Gensim is basically a short form for this generate similar, right? Generate similar, what you can see here. So it is a popular open source NLP library used for unsupervised topic modeling. Topic modeling is one of the subject in NLP where we need to find the topics based on the article or based on the document. So we are going to find what is that subject related to, right? So that is basically a top modeling. So Gensim is basically used, in a topic modeling. So let's understand the terms used in a Gensim and how to interpret and how to create a dictionary and things like that, right? So first term is a document. Document is a simple text in the form of statements, right? So or the sentence. So that is basically simple text, all right? And you can see this document, human machine interface for lab ABC computer application, a simple document, nothing complex here. Then comes the corpus. Corpus is a collection of documents. I have a document, one. So I will have another document, suppose say here, okay, whatever it is, right? So that is one more document. I will have one more document, right? So that is a collection of documents is called a corpus. And vector, vector is a mathematically convenient representation of a document. So for this document, I will give some number, right? So that number is nothing but a vector. So instead of telling this entire sentence, I will represent this with the help of a some number that is nothing but a vector. All right. And a model, an algorithm for transforming vectors from one representation to another, right? So I have a vector. So transforming from one vector to another vector. So that is nothing but a model. All right. So let's understand one by one. Okay. So yeah, again here you can see a corpus. So a document, 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 document. A collection of documents is nothing but a corpus. All right. And let's see some more. So the vector, mathematically convenient representation of a document. So let's understand that one. So here I'm importing a pprint. Pprint is basically a pretty print that we use in a Gensim, right? It's like a print only, but in Gensim we use a pprint. All right. Let's understand with some example here and see that how all these terms we can interpret with the help of this example. Say that there are some words, right, for a of. So these are all basically what? Some stop words. So I'm creating my own stop word list here, right? Set will make sure that there are no duplicates. And this is basically a set of words, list of words that I'm going to split it by space. So every space is basically one word, right? Those words are basically stop list, right? So now what I'm going to do, I already have a documents here, right? So corpus, text underscore corpus, that is what we have seen. So now how it is going to work here? Let's understand. So first, it is going to check this condition, right? So when I say condition, it is basically a for loop and it is going to get one document at a time from this text corpus. So above we have seen text corpus, which is a collection of documents. So I will get a document, then document will be passed over here. Then I have one more for loop for every word in the document. I'll find that word and convert that into a lower, right? So then I will split. So split basically word by word, because it is a document, collection of words in the document. That words will be converted into lower, then will be split. Split means word by word, word by word, word by word, and those word will be passed over here, and we'll check that if that word not in the stop list, this guy. If it is not in the stop list, then that particular word will be stored in this text. Okay, so let's understand. I will fetch the document from the text corpus document, and in the document I will split word by word, word by word, word by word, right? So then these words will be checked whether they are in the stop list. If they are not in the stop list, that word will be stored in texts. That is nothing but this guy. All right. So now I am going to import the default dict. So this is going to keep a count of word frequencies, right? So that I will import from the collections. So then I'm going to instantiate this default dict into this frequency. All right. So now what I'm going to do, this text I'm going to check here. For every text in the texts, right? For every text in the text, again that text will be passed here, and each text will be checked. Okay, for every token in text, right? Texts are nothing but tokens. So for every token in the text, I will take that text and load it into this frequency. Frequency token plus equal to 1 means is like adding a counter. One by one, I'm going to add it into this frequency. All right. So that is what this piece of code is doing. Then what I'm going to do, only keep words that appear more than once. So what I'm going to do, I will take this frequency, right? So first what I'm going to do, first I'm going to check the text in the texts, right? So then in the text, for every token in the text, because this text will be passed here, for every token in the text, right? If frequency of a token greater than 1, right? If it is appearing more than once, then that token will be taken here and stored into this particular corpus, processed underscore corpus. All right. And this text is nothing but this guy only. All right. So then I am going to print this processed corpus. Let's execute. Hold on. I did not executed all these guys. Just a second. Okay. Now you can see. So here we have a human interface and computer. So the very first document here, right? So human interface documents. So this, what we are going to do here in this, here we are fetching only the tokens which are greater than 1. Human, yes, one time appearing, and should be, okay, one more time. So greater than 1 time, yes, it is there. And the next interface we have 1 time, and we have one more time, right? So greater than 1 time. And other than that, you will see some of the stop words. Those stop words we have already removed here, not in the stop list, right? So that is why you see all this data which are greater than 1. I mean in terms of a frequency, right? So you can change it to different number if you want, but I have taken only 1 here, right? So now I'm going to create a dictionary. So dictionaries are available in the Corpora, right? Creating a dictionaries which helps during a topic modeling. All right. So during a topic modeling, we need to have this kind of a dictionary. So where we can, refer the dictionary and convert into some numbers and IDs, things like that. All right. So for that, what I'm going to do, I'm going to import a corpora from Gensim, right? So within the corpora, I have a dictionary, right? So in the dictionary, I'm going to pass all this processed corpus. That is nothing but all these guys, right? Everything will be stored in one of the object called a dictionary, and I will print that dictionary. Let's see. So here dictionary is a set where it is having 12 unique tokens. So if you look into all this data, you will find 12 unique uh, words. 12 unique words, those are all stored in this dictionary. All right. So now vector representation. So what is vector representation? From one vector to another vector, right? So I'm going to use this dictionary and I will say dot token to ID. So I will take all these tokens and I'll convert that into ID and I'm going to print that. So as you can see, computer is assigned 0 and EPS 8, things like that. All right. So that is vector representation. All right. Now let's look into the model. So as we discussed, model an algorithm for transforming vectors from one representation to another, right? So again, it's always good practice to test data, small data, because if you have too much of data, so and the model does not work, then you are unnecessarily wasting your time. So it is better to test it and apply onto the huge amount of data. If a model doesn't work, you are going to waste a lot of time, right? So that's why it's a good practice to testing a small text. So new doc, so very small document here, human-computer interaction. So the dictionary which I have created, I'm going to use that, and I will say dot doc to BOW. That is nothing but document to bag of words, right? So document to bag of words, then I'm going to give a new doc, which is nothing but this guy. Then I will convert into lowercase, then I will split. So it will look like human, one text, computer, and another, and interaction, right? That's how it is going to split. So then I'm going to store that into this new doc. All right. So I'll apply this dictionary and I will print this new vec. Let's see that. So you can see that 0 and 1, 1 and 1. So what are they? Right. So they are basically ID and occurrence, how many times they are occurring. So what is the 0 here? If we go back and look into this computer, right, is a 0, right? That is 0. And how many times it is occurring? Only one time, right? So in this case, it is occurring only one time. And human, what is the ID for human? Human is basically 1 and it is occurring only one time. And this interaction, we do not have an interaction in the dictionary, right? So that is why it is not printing. So what I will do, I will just write one more word, computer, right? Let's execute. You see that computer is occurring 2 times. Which data is that? That is basically 0th data, right? 0 is basically a computer and it is occurring 2 times in this new document, right? So that is how you can interpret. So we make use of a dictionary. This is nothing but this dictionary, and we assign ID here, right? This ID, and we'll take that ID from here and we'll also give a new vector that is nothing but an occurrence. right? That's how you can interpret this. Now what I'm going to do, I'm going to apply this dictionary to the whole text, right? The whole text. Here we have just tested. I'm going to apply on this whole text. That whole text is nothing but over, where is that? Yeah, processed, coming from the processed corpus. Processed corpus is basically these guys, right? Processed corpus. So I'm going to apply on this whole corpus. Then I will take text one by one, and I will pass it here. Then I will apply this doc to DOW, document to bag of words. So then I will store it in this guy, and I'm printing it. Then it looks like this, right? So 0, 1, so same thing like this, just like this. Okay, what is the ID and how many times it is occurring? So accordingly, it is going to print. Let's see first one, 0, 1. So basically, it's a human. Human is what is the ID here? 1 and 1. So this guy is a human here. So otherwise, start from alphabetically. Let's talk computer. 0, right? How many times it is occurring? Only one time. And the next one is 1 ID. What is the ID 1? ID 1 is a human, and how many times it is occurring? In the first document, only one time. That is basically 1. And what is the 2? 2 is basically interface. So yes, we have an interface in the first document, and it is occurring only one time. All right. So that's how you can interpret. All right. So fine, and let's look into this 2 guy, right? Fourth document, 1, 2, 3, and fourth document. So ID is 5. What is the ID 5? ID 5 is a system. And in the fourth document, 1, 2, 3, 4. So we can see that system is appearing 2 times. ID 5 system and appearing 2 times, right? So that's how you can interpret this, right? So now there is something called models, right? So in the models, I'm going to use a TF-IDF model here. So I'm going to convert vectors into another form, right? So these models can be imported from the Gensim, and the models.tf-idf model and this bag of words corpus I'm passing, right? So then again, I'm using this system minus into lowers and split, and I'm going to pass these words into these words. All right. So the TF-IDF model I am applying. All right. So you can see that this is how it is going to be transformed. System ID is a 5, right? And the vector is basically this one. Minus is how much? Minus is 11, and the TF-IDF vector is basically this guy. So we have just tested it, right? So you can pass any data here. You can pass any data, and you'll be able to see your data over there. All right. So you will be able to see the IDs and the vector, right? So IDs are nothing but your text here. So yeah, I just made use of this TF-IDF model, and yeah, you can go ahead and use that one. All right. So what I'm going to do, I'm going to use this text file and do some processing here. So I'm importing a corpora from the Gensim and a pprint as usual. And there is something called a simple preprocess. So it is available in the gensim.utils. All right. So I'm going to use the corpora.dictionary, which is already there. Then I'm applying a simple preprocess. And what is this line? This line is coming from this guy. I have a sample data, sample.txt, and I'm going to read line by line, and I will pass it over here, and I'll apply a simple preprocess. right? Simple pre-process is again removing stop words and small pre-processing steps I will be able to apply here with the help of this utility. All right. So I'm going to store everything inside this dict underscore stf, and I will use that and apply a token to ID. So this is how you will be able to see, right? Details, 0, files, sample. So this is basically the data I have in the sample.txt. All right. So yeah, you can use any data here and see how things will work. All right. So yeah, that's all in this video. Thank you for watching this video. Keep learning. Thank you.